In this question, it is given that f of x is a polynomial of degree 4 with leading coefficient as 1, satisfying f of 1 is equal to 1, f of 2 is equal to 2, f of 3 is equal to 3. Then the integral part of f of minus 1 plus f of 5 by f of 0 plus f of 4, how much? That is, what is the main question? Let us observe. Integral part of f of minus 1 plus f of 5 by f of 0 plus f of 4. For this, the integral part is required. The options are, first option is 0, second option is 5, third option is 1, fourth option is minus 1. The crucial idea in making a successful attempt to solve this question is, you please observe the nature of f of x. It is a fourth degree polynomial. Moreover, the leading coefficient is 1. That is, the coefficient of x power 4 is 1. Not only that, f of 1 is given to be 1, f of 2 is given to be 2, f of 3 is 3. So, there is no harm in assuming that f of x is equal to x minus 1 into x minus 2 into x minus 3 into, so far we are able to observe only third degree, into x minus k plus x. You have a look over that. X into x into x into x, no doubt it is a fourth degree. Coefficient of x power 4 is 1. Not only that, what is f of 1? What is f of 1? 0 plus 1, 1. f of 2, 0 plus 2, 2. f of 3, 0 plus 3, 3. All the conditions have been satisfied. This is the key point here to note. Here we have put x minus k. What is k? We don't want it in the beginning. Let us see what happens at the end. Let us face the question. What are the things required here? 4 things are required. Number 1, f of minus 1, f of 5, f of 0 and f of 4. Let us try to find them. What is f of minus 1? Minus 1 minus 1. Minus 1 minus 2. Minus 1 minus 3. Minus 1 minus k. Plus minus 1. In the place of x we have minus 1. Total minus into minus into minus into minus. Plus 2 3s are 4, 6, 6 4s are 24. This is 24 into 1 plus k minus 1. This is 24k. 24 minus 1, 23. Therefore, we could have estimated what f of minus 1 is. Well done. Next, f of 5. What is f of 5? 5 minus 1, 4 into 5 minus 2, 5 minus 3, 5 minus k plus 5. Altogether, 4 3s are 12, 12 2s are 24, 24 into 5 minus k, 24 into 5, 120, 24 into k minus 24k plus 5. Isn't it? 4 3s are 12, 12 2s are 24, 24 into 5, 5 24s are 120, 120. This is 24 into k, 24k plus 5. It is 125 minus 24k. These two are the things available in the numerator. Let us now concentrate on the things available in the denominator. What are the things to be determined now? F of 0 is therefore equal to, put x is equal to 0. 0 minus 1. Minus 1 into minus 2 into minus 3 into minus k plus 0. Altogether this is 6k, just 6k. Minus into minus into minus into minus. It is positive. 1 into 2 into 3 into k is 6k. Stop that. This is f of 0. What f of 4 is? The last thing that we are supposed to find in estimating this answer. F of 4 is also a bit known. What is f of 4? 4 minus 1, 3. 4 minus 2, 2. 4 minus 3, 1 into 4 minus k plus 4. Total 3 2s are 6, 6 1s are 6, 6 4s are 24, 6 into k minus 6k plus 4, altogether 28 minus 6k. Well, we could have found almost all the things required to make an attack on the question. Let us now make use of all this. Therefore, integral part of f of minus 1 plus f of 5 by f of 0 plus f of 4 is equal to, think of the sum of these two. The beautiful thing here we observe is plus 24k and minus 24k will go away. 125 plus 23, what is that? 148 by, what is f of 0 plus f of 4? Add these two. Plus 6k and minus 6k will go away, leaving you 28. That is 28. We don't want actual value. We want to have the integral part of that value. And everybody knows that 148 by 28 means 28 goes 5 times, 5 28s are 140. Beyond that some 8 remains. The integral part is 5. What is the integral part? 5. Is it available in the among options? Yes, it is. What is the right option? Second option, that is 5 is the correct option. In this question, f of x has been given as a series, of course, with finite number of non-zero terms. F of x is equal to 5 plus sigma r is equal to 1 to 2010 a 2r minus 1 x power 2r minus 1. That is f of x. And he has given us another additional information. F of minus 1 is 4. Then what f of 1 is? What is f of 1? We are supposed to find f of 1. The available 4 options are, the first option is 2, second option is 6, third option is 5, fourth option is 4. To have a clear-cut idea, let us first see what f of x is. What is the given f of x? F of x is equal to, what is that? 5 plus sigma r is equal to 1 to 2010 a 2r minus 1 x power 2r minus 1. That is the function given. You please observe carefully the suffix here and exponent here. 2r minus 1, what is that? Always it is an odd integer. If you place r is equal to 1, it becomes 1. If you place r is equal to 2, it becomes 3. If you place r is equal to 3, it becomes 5. Like that. So, with that idea, let us expand this f of x. What is f of x? a1x plus a3x cube plus a5x power 5 plus a7x power 7 plus etc. What would be the last term in this summation? Take r is equal to 2010. What is 2r? 4020 minus 1 is 4019. A 4019 x power 4019. This is f of x. Now, our plan is how to use the data, how to get the required. Data is f of minus 1. Let us use it. And required is f of 1. Let us find it. First of all, what is f of minus 1? It is given to be 4. F of minus 1. What is f of minus 1 actually? 5. A1 into minus 1 minus A1 minus A3 minus A5 minus A7 etc. etc. Even the last term is also negative, minus A4019. But it is given to be some 4. It is 4. Well, what is required? F of 1. What is f of 1? take 1 in the place of x, what is going to happen? 5 plus a1 plus a3 plus a5 and so on plus a4019 is equal to how much? That is to be found. That is to be obtained. We do not know the value. Let me assume it to be some k. So we require the value of k. Let me now add these two equations. Let me see what is going to happen. 5 plus 5, 10. Cancel is equal to 4 plus k on the right hand side you will be having. The required unknown, that is k, is directly obtained here to be some 6. What is k? Just nothing but f of 1. We have named it. Therefore, what is f of 1? 6. Hence, the available option, that is the second option, is the right option. It is 6. So, in answering this question, what idea could help us? The idea of expanding f of x accurately by observing the nature of the terms involved in this summation. And f of minus 1 is given, f of 1 is asked. You are supposed to use both of them simultaneously at a time. You will be getting f of 1. What is f of 1? 6 is the right option. That is, second option is the right option. In this question, we have f of x is equal to ax plus b, where a and b are rational numbers with b not equal to 0, such that f of 1 less than or equal to f of 2, f of 3 greater than or equal to f of 4. Then the value of sigma r is equal to 1 to 2n minus 1 of f of root 2r by f of root 3, where n is a natural number, is a peculiar question. This is the way of understanding the given function plays the main role, vital role here in solving the question. Moreover, let us observe the options. The first option is n, second option is 1, third option is 0, and the fourth option is n square. Which option is going to be the correct option? Let us observe. Well, in the beginning, what is f of x? F of x is equal to ax plus b. By looking at f of x is equal to ax plus b, every student of mathematics can easily recognize that it corresponds to a straight line, as it is a linear expression. Y is equal to ax plus b, surely a straight line. Okay, a and b are rational numbers such that f of 1 is greater than or equal to f of 2 and f of 3 greater than or equal to f of 4. There lies the actual mystery. Let us use the data. How can it help us? Let us see. And just now we are believing that the graph of f of x is a straight line. Let me plot 1, 2, 3, 4. Let me try to represent the data. F of 1 is less than or equal to f of 2. That is, if f of 1 lies here, f of 2 lies here. F of 1 is less than or equal to f of 2. Again, f of 3 greater than or equal to f of 4. This is f of 3, say here. F of 4, say here. Do you believe that that is the nature of a straight line? As per the data, as per the question, this entirely belongs to the representation of the graph of a single function. It cannot be a straight line. Therefore, in order to satisfy that f of 1 less than or equal to f of 2 and f of 3 greater than or equal to f of 4, it must happen that f of 1 is equal to f of 2 is equal to f of 3 is equal to f of 4. There is no other go. Is equal to, say, some k. We don't know. So what does this information imply? F of x is a constant function. If f is a constant function, every one of us know that its derivative is 0. F dash x is 0. What is f dash x? A is equal to 0, isn't it? From this information, we can infer that f is a constant function. Constant function. As and when you believe and see that f is a constant function, f dash x is equal to 0 implies a is equal to 0 implies f of x is equal to b. F of 1 is b, f of 2 is b, f of 3 is b, f of 4 is b, f of every value is b. Well, let us now make use of this one to calculate the required one. What is the question actually? What is the actual question? The question is the value of sigma r is equal to 1 to 2n minus 1. R is equal to 1 to 2n minus 1. F of root 2r by f of root 3 and belongs to n. And belongs to n. So this is equal to, as f of x is a constant function, as f of x is a constant function, f of everything is b. F of 1 is b, f of 2 is b, f of root 2 is b, f of root 3 is also b. F of root 3 is also b. In the question, this is we have traced. You have this like this. You are supposed to have the question. F of root 2 is b. R takes 1. So b. Next 3b. Next 5b. Next 7b. And so on, etc. 2n minus 1 into b by what is f of root 3? B. How does it become b? F of root 2 is b. R is 1. Next, take r is equal to 2. Then what happens? 2n minus 1 only. Up to that, isn't it? Therefore, this is b plus 3b plus 5b plus etc. It is n square b by b, leaving you n square. Leaving you. So, what is the right option? N square. The fourth option is the right option. Fourth option is the right option. Another simple and standard question we are going to face. The domain of the function f of x is equal to 1 by x minus integral part of x. To estimate the domain of f of x, you have to see that the denominator does not vanish. Enough precautions are to be taken such that x minus integral part of x may not be 0. Let us now see, when can that become 0? It can become 0 when x minus integral part of x is 0. That is, x is equal to integral part of x, and it happens when and only when x is an integer. Integral part of 1 is 1, integral part of 2 is 2, integral part of 3 is 3. In all these cases, x minus integral part of x becomes 0. Not only that, integral part of minus 1 is minus 1, integral part of minus 2 is minus 2, integral part of minus 3 is minus 3. In a nutshell, if x is an integer, x minus integral part of x is surely 0, and we should see that that does not happen. So for that, domain of f, for domain of f, what should you have? X minus integral part of x not equal to 0. That is, x not equal to integral part of x. That is, x does not belong to z. That is, x is not an integer. This sense is conveyed among all the options. The third option is the right option in which this sense is conveyed. You observe the third option. First option is n. Not the case. Second option is 0 to infinity. Not that case. Third option is r minus 0 plus or minus 1 plus or minus 2 plus or minus 3, etc. And the last option is for r minus n. Here we write df as r minus z, that is the set of integers. This can also be written as r minus 0 plus or minus 1, plus or minus 2, plus or minus 3, etc., etc., etc. And this can be observed in the third option. What is the right option? Third option is the right option. Domain of the function log f of x is equal to log to the base 2 of log to the base 4 of log to the base 2 of log to the base 3 of x squared plus 4x minus 23. This we require. So, a repeated application of logarithmic function has been seen here. The options given are the first option, open interval minus 8 to 4. Second option, open interval minus infinity to minus 8 union open interval 4 to 8. The third option, open interval minus 4 to 8. The fourth option, open interval minus infinity to minus 4 union 8 open interval 8 to infinity. Let us see the nature of the function. What is f of x? F of x is equal to log to the base 2 of log to the base 4 of log to the base 2 of log to the base 3 of x square plus 4x minus 23. You must deal with that very, very, very carefully. Yes, altogether, a logarithmic function has been applied 4 times. It appears 4 times. Well, let us start. Let us attend to this logarithmic function. Log of, call me this entire thing some k. This logarithm can be defined only when k is greater than 0. Isn't it? This is greater than 0. This is greater than 0. What does it mean? Log to the base 4 of log to the base 2 of log to the base 3 of x square plus 4x minus 23 greater than 0. Now, all these bases are greater than 1. Logarithmic function is an increasing function. This 0 you can have log 1. Or otherwise, this is greater than 4 power 0. That is log to the base 2 of log to the base 3 of x square plus 4x minus 23 is greater than 4 power 0. What is 4 power 0? 1. Again, let me use this as some k. Log k to the base 2 is greater than 1. Then k is greater than 2 power 1. That is log to the base 3 of x square plus 4x minus 23 is greater than 2 power 1. That is 2. Therefore, x square plus 4x minus 23 is greater than 3 square. 3 square is 9. Therefore, x square plus 4x minus 32 is greater than 0. And we can easily have the factors for this. X plus 8 into x minus 4 greater than 0. X plus 8 into x minus 4 greater than 0. By using sign concept, it is very easy to trace that x belongs to, it does not lie between minus 8 and 4. That is, it lies behind minus 8 or beyond 4. Just a minute, this is plus 4. Therefore, this is minus infinity to minus 8 union 4 to infinity. 4 to infinity. Minus infinity to minus 8 union 4 to infinity. By the basic knowledge of quadratic expressions, we shall be able to have this answer. So, what is the right option? Option B is the right option. Option B is the right option. The next question is, The function given here is f of x is equal to square root of 5 mod x minus x square minus 6. We are asked to have the domain of this function. The domain of the function f of x is equal to square root of 5 mod x minus x square minus 6 is required. Among the options, the first option is open interval minus infinity to 2 union open interval 3 to infinity. The second option is closed interval minus 3 to minus 2 union closed interval 2 to 3. Third option is open interval minus infinity to minus 2 union open interval 2 to 3. And the fourth option is the set of real numbers minus the set containing minus 3, minus 2, 2 and 3. Let us observe and discuss with the domain of f. What is the function given? F of x is equal to square root of 5 mod x minus x square minus 6. For domain of f, what should you have? 5 mod x minus x square minus 6 greater than 0 or greater than or equal to 0. We do not bother about it even if it becomes 0 also, because root 0 is 0. So nothing, there is no problem in finding f of x even when this happens to 0. This is greater than or equal to 0. Good. This can be written again as x square minus 5 mod x plus 6 is less than or equal to 0. To avoid confusion, let us observe the two cases of this expression. Case 1. What is the case 1 that must be discussed with? X is greater than 0. If x is positive, what do you say about mod x? X. In this case, x square minus 5x plus 6 less than or equal to 0 implies x minus 2 into x minus 3 is less than or equal to 0. By observing the sign system, you can see that x belongs to the closed interval 2 to 3. X belongs to the closed interval 2 to 3. This is case 1. Well, what about case 2? What is case 2? X less than 0. X less than 0. Then what is the case? Implies in this case mod x is equal to how much? Minus 6. What is this condition? X square plus 5x plus 6 less than or equal to 0. We have taken minus 6 in the place of mod x because x is less than 0, so that this relation becomes x square plus 5x plus 6 less than or equal to 0. It is again x plus 3 into x plus 2 less than or equal to 0. So by the previous, the similar type of knowledge, we say that x belongs to minus 3 to minus 2. Minus 3 to minus 2. X belongs to minus 3 to minus 2. Now, let us have a union of these two. That gives us the answer. First case is open it closed interval 2 to 3. The second case is minus 3 to minus 2. Let us have a union of these two. Hence, the domain, required domain is closed interval minus 3 to minus 2 union closed interval 2 to 3, and that is surely available in the second option. What is the right option? Second option is the right option. Therefore, the domain of f is closed interval minus 3 to minus 2 union closed interval 2 to 3. The second option is of course the right option. The next question is the range of the function. Here in this question we are asked to find the range of the given function. What is the given function? Y is equal to, of course, that is f of x is equal to 2 power x minus 2 power minus x by 2 power x plus 2 power minus x. What will be the range of the function? The first option is entire set of reals. Second option is open interval minus 1 to 1. Third option is closed interval minus 1 to 1. And the fourth option is the open interval 0 to 1. Let us observe the nature of this y. Y is equal to 2 power x minus 2 power minus x by 2 power x plus 2 power minus x. Let me multiply both numerator and denominator with 2 power x. Let me see what happens. With what quantity? 2 power x, that is 2 power x by 2 power x. 2 power x into 2 power x, 2 power 2x. 2 power minus x into 2 power x, 2 power 0 by 2 power x into 2 power x, 2 power 2x. This is again 2 power 0. What is 2 power 0? 1. So this is y. Let me now take what 1 by y is. Why should we take like that? Let us discuss it later. You please consider what is 1 by y. 2 power 2x plus 1 by 2 power 2x minus 1. Now let me apply one of the most standard and famous properties from ratios and proportion, that is componendo dividendo. What happens? 1 by y. 1 plus y by 1 minus y is equal to 2 power 2x plus 1 plus 2 power 2x minus 1 by 2 power 2x plus 1 minus 2 power 2x minus 1. What happens to the fate of this? In the numerator, 1 and 1 can be cancelled, leaving you 2 into 2 power 2x. And in the denominator, 2 power 2x will be cancelled, leaving you 1 plus 1, that is 2. It is just nothing but 2 power 2x. Therefore, what you have here, 1 plus y by 1 minus y is equal to 2 power 2x. And we all know about the nature of 2 power 2x. It is of course an exponential function, can never be negative, absolutely positive. Therefore, 1 plus y by 1 minus y is greater than 0. Let me multiply. So 1 plus y by 1 minus y is greater than 0. Let me multiply this with 1 plus y on both numerator and denominator. What happens? 1 plus y whole square by 1 plus y into 1 minus y, 1 minus y square is greater than 0. Isn't it? Already 1 minus y is here. I am multiplying it with 1 plus y. 1 minus y into 1 plus y becomes 1 minus y square. You observe this fraction. This must be positive. Numerator, by birth it is positive because it is a perfect square. So in order to have this entire fraction positive, what must we have? 1 minus y square is greater than 0. It does mean that y square minus 1 less than 0. That is y plus 1 into y minus 1 less than 0. Y plus 1 into y minus 1 less than 0. That is y should belong to open interval minus 1 to 1. Y should belong to open interval minus 1 to 1. Hence the range of this expression is open interval minus 1 to 1, and it is surely available in the second option given. So what is the right option? Second option. The next question, which among the following functions is the inverse of itself? There are certain functions you can see that they become the inverse of themselves. That is f is equal to f inverse, or f circle f is equal to I. F circle f is equal to I. Out of such functions, one of the famous functions is, you please observe this, f of x is equal to ax plus b by cx minus a. X not equal to a by c. Of course, that is denominator is not equal to 0. You please observe very carefully about the nature of this function. It is a fraction. Numerator is a linear expression. Denominator is also a linear expression. Coefficient of x in the numerator by coefficient of x in the denominator. What is that? a by minus a. What is it? Minus 1. Minus 1. You can easily observe that this is the inverse of itself. You can find F inverse with the usual customary procedure or by using the formula also. You will get F inverse as the same one. Let us now check. Let us now check which of the following options is in this form. What is the first option? Y is equal to a power 2 log x. Second option, y is equal to 5 power x square plus 2. Third option, y is equal to 1 plus x square by 1 minus x square. It is quadratic. We are not able to believe it. Fourth one, y is equal to 1 minus x by 1 plus x. It is in this form. Coefficient of x in the numerator by coefficient of x in the denominator. What is that? Among fourth option, minus 1 by 1. It is minus 1. So that satisfies this condition. Hence, among the four options, what is the self-invertible function? Fourth one. Now and then you shall be facing some questions of this form. F of x is equal to 3x plus 123 by 1547x minus 1547x minus 3. What is F circle, F circle, F circle, F circle, F circle, F of 1? You may be facing such question. As the context arises, I would like to mention this concept. You observe here, 3 minus 3. 3x, coefficient of x in the numerator by constant term. In the previous one, yes, we are mistaken. Coefficient of x by constant term. What is that? Minus 1. Coefficient of x by constant term is minus 1. So, F circle F. I. What is I? The identity function. I circle I circle I have 1. 1. I have x. X. I have 1. 1. You need not calculate anything at all. So, this is 1. And this is the basic character of this particular function. And we are happy to see the fourth option in this form. Therefore, that is the self-invertible function. If you are asked to have one more such thing, then forget them. F of 1. You just put x is equal to 1 in this and get it simplified. Thereby you will be getting the required answer for such questions. Yes. So here, what is the right option? Fourth option, that is y is equal to 1 minus x by 1 plus x. Quotient of x in the numerator, minus 1. Constant term in the denominator, 1. Minus 1 by 1, minus 1. So, let us make it corrected, that expression. Coefficient of x in the numerator by constant term in the denominator. What is that? Minus 1. Thereby, we declare that that is self-invertible. That is the inverse of itself. Yes. In this question, the range of the function f of x is equal to cos square x by 4 plus sin x by 4 whenever x is a real number is asked. There is the range of the function is required in the present question. The first option is closed interval 0 to 5 by 4. Second option is closed interval 1 to 5 by 4. Third option is closed interval minus 1 to 5 by 4. Open interval minus 1 to 5 by 4. And the fourth option is closed interval minus 1 to 5 by 4. Let us see. Let us have a look over the given function. What is the function given? F of x is equal to, what is f of x given? Cos square x by 4 plus sin x by 4. Sin x by 4. Okay, let me simplify this as cos square x by 4 can be written as 1 minus sin square x by 4 plus sin x by 4. Am I right? Again, this is 1 minus sin square x by 4 minus sin x by 4. I would like to observe this as a perfect square. Then what is to be added here? Sine square x by 4 minus sine x by 4, come on, plus 1 by 4 minus 1 by 4. Observe these three. What do you say about it? This is equal to 1 minus, this is sine x minus 1 by 2 whole square plus 1 by 4. Minus of minus 1 by 4 is plus 1 by 4. It is in the form a square plus b square minus 2ab. I am sorry. Yes. Sin x by 4 minus half whole square plus 1 by 4. 1 plus 1 by 4 is again what is 1 plus 1 by 4? 5 by 4. Therefore, f of x is equal to 5 by 4 minus sin x by 4 minus 1 by 2 whole square. No doubt this is always less than or equal to 5 by 4. No doubt this is always less than or equal to 5 by 4. So the maximum value of f of x is 5 by 4. It cannot exceed 5 by 4. Now it remains for us to have the minimum value of f of x. Minimum value of f of x. If you are able to trace it, you can easily have the answer. Look here. Therefore, f of x is always less than or equal to 5 by 4. Call this relation 1. Okay. What is the minimum value of sin x by 4? Sin x by 4 always lies between minus 1 and 1. Maximum value of sin x by 4 is 1, but the minimum value of sin x by 4 is minus 1. Therefore, minimum value of f. How can you estimate? 5 by 4 minus 1 minus 1 by 2 whole square. 5 by 4 minus, what is minus 1 by 2? Minus 3 by 2. Minus 3 by 2 whole square means 9 by 4. Isn't it? Minus 3 by 2, that is minus 9 by 4. 5 by 4 minus 9 by 4. What is 5 by 4 minus 9 by 4? Minus 4 by 4. What is that? Minus 1. So, minimum value of f is minus 1. Maximum value of f is 5 by 4. It lies between minus 1 and 5 by 4. What is the correct option among the 4 given options? The fourth option is the right option. That is closed interval minus 1 to 5 by 4. Therefore, range is closed interval minus 1 to 5 by 4. This way, note it as. What does this symbol stand for? Range of the function. Yes. What is the right option? Fourth option is the right option.